In the current landscape of AI, the narrative you will hear more often is about scaling, making bigger models with more data and more computational power, and somehow this will lead to AGI and ASI. Personally, I'm very hesitant to use these terms. They are good buzzwords for headlines, but unfortunately, they are not formally defined. But before we get to that, let's pause and ask something even more fundamental. What if we are scaling the wrong thing in the first place? Let's try to unpack this with a simple analogy. Newton's theory of gravity worked well until we tried explaining the orbit of Mercury. No matter how much we refined, the math didn't fit. Why? Because the framework itself was incomplete. It took Einstein's new paradigm, general relativity, to even allow for the concepts of space-time curvature, which eventually explained the orbit of Mercury. It wasn't about having better maths, it was asking the right question. Does our fundamentals even capable of producing the truth we are after? Today, I believe we are in a similar place with AI. Traditional AI models, including largest language models, are built to predict, not to think. Their architecture and fundamental math doesn't inherently allow for internal associations and creativity, something that wasn't already in the data. We can expend as much resources as we want, but if the fundamentals doesn't allow for something, the ceiling is already set. It's like having the designs of a motorcycle and somehow expecting it to fly. Of course, we can make it fly by building ramps and riding it through them and claiming, look, it is flying. But it is a form of flying, but we also have to understand that the claim is very misleading. The core issue here is this. Do we have the right foundational framework to build generalized intelligence? Our journey at JN Research started with this fundamental question. To get the answer, we went back to the drawing board to try to understand human brain as an information processing system from the first principles. Does it sound ambitious? Of course it does. But the human brain is the only system in the universe that exhibits generalized intelligence, something we want to achieve and surpass in machines. That is the only known reference we have. Using our understanding, we build adaptons, a fundamental unit that autonomously adapt while exhibiting graded action and sub-threshold potentials, just like a biological neuron. The idea was simple. We wanted to build an artificial neuron which is foundationally compatible with its biological counterpart so that it can inherently allow for higher cognitive functions to emerge when it is used in a system. Using adaptons, we built small working prototypes of artificial brains, and they have already started showing early signs of higher cognitive functions emerging inherently. This gives us confidence that we are on the right track. I'm going to end this video with a very simple question worth thinking about. With traditional AI, do we have the right foundational framework to build generalized human-like intelligence? If the answer is no, we do not need more power or infrastructure. We need a better start, something we are exploring at JN Research.